Hey guys, welcome to my lesson presentation of Module 3, chapters over length, volume, and area. Oops, sorry. So the first thing we're going to talk about is the doubling system. And the big thing with doubling systems is we're going to start by using mouthfuls. And so we have an abbreviation here, which is MF, which just stands for simply mouthfuls. So we see that one mouthful is just one mouthful. But two mouthfuls, which we're doubling, which doubling is also a simple term for multiplying by two, will give us a jigger. So two mouthfuls will give us a jigger. Four mouthfuls will give us a jack, which we could also just say, times two as well. 8 mouthfuls will give us a jill. 16 mouthfuls will give us a cup, and a cup is more of a measurement that we already are used to, just with our system of, I guess we could just say measuring system, and then multiply that by 2 and we'll get 36 pints. So simply just the doubling system is just multiplying by 2 using our mouthfuls. Sorry. So our next question was, if we added one of each measurement smaller than a pail, would the pail overflow, fill perfectly, or have room for more? So talking about this, we want to kind of talk about how much would fill our pail up. So in our pail, we have 2 gallons, 4 bottles, 8 quarts, 16 pints, 32 cups, 64 jills, 128 jacks, 256 jiggers, and 512 mouthfuls total. So we can see one mouthful, and this is what we learned using our doubling method. One mouthful just equals one mouthful. 2 mouthfuls is a jigger. 4 is a jack. 8 is a jill. 16 is a cup. 32 is a pint. And I said 36 was a pint previously. It's actually 32. I'm correcting myself. 64 is a quart. 128 is a bottle. 256 is a gallon, and 512 mouthfuls is a full pail. So let's add all of these together. So our mouthful, jigger, jack, jill, cup, pint, quart, bottle, and gallon, and we're going to see what we have left for our pail. We are left with 512, so that means we have room for one more. If our pail, if 512 mouthful fills up our pail, and we only added up to 511, we would have room for more. Pretty simple. So now we're going to get to something that's a little bit more tedious. We're going to get into area and perimeter of triangles. So using our homework experience and questions, we're going to look at this. So define area. We know the formula for area is 1/2 base times height. So our inputs for our base, B would equal 82.3, and we could see that down here. Let me get my drawing tool out. We can see we get that from our base, because this bottom platform is what our base is and what our shape stands on. So that would kind of just be our platform, our base. So if our formula is 1/2 base times height, our height would be right here. So all we would do is multiply that together. So we would have A equals 1/2 times our base, which is 82.3, times our 41 meters. And then our solution would end up being 1,687.15 meters square. And the reason why we get meters square is because we have 2 meters. Well, we technically have 1 meter for our 82.3 for our base, and we technically have another meter for our height, our 41. And so when we're multiplying meters, we will actually get meters square. So it's pretty simple. So looking at perimeter, and I want to point something out before we go any further. Let me erase this real quick. So when we're talking about perimeter and area, let me point out that perimeter is the outside. So if we were to have a fenced-in backyard, the perimeter would be the outside, the measurement of the fence, and the inside would be the area. So looking at this image here at our triangle, we could see our fence would consist of 48 meters, 69 meters, and 82.3 meters, and our area would be in the inside where 41 meters is. But everything on the outside equals perimeter. And how to find perimeter is just the sum of all the sides. So what we're going to do is add up 48 meters, 69 meters, 82.3 meters, and then that will give us 199.3 meters. And you might be wondering and thinking about, well, she just said in area we would get meters square, correct? But I also said that because when we multiply our units, we will double our units, but when we're simply adding, we will stay with the same units, and that goes same as inches. It'll go the same with inches, feet, and any kind of measurements like that, like meters. So let's move on. So we have another image here. We're going to do area and perimeter of the triangle. So this image looks a little bit different. We don't have the inside right here. So we're going to show you what we do. So instead of our base being on the bottom like normally is, this shape is actually rotated because we can see that where the right triangle is right here, that is our 90-degree angle. We see that is sideways, and normally when we have the right triangle, it's like this. So we're going to think of that as our base. So again, our formula is A equals 1/2 base times height. So our inputs would be B would equal 88.8 inches. And notice that we're doing inches this time, not meters. So we know why that's our base. So let's talk about height. So for our height, last time we got our height where area was, correct? Well, like I said, this base, this triangle is rotated. So actually our height would be 37.0 inches right here, because that is how tall this angle is. And if that equals H, this equals B. Sorry, that's a little messed up of a B. So our input would be 88.8 for our base and 37 inches for our height. So we're going to go ahead and plug that into the formula. So A equals 1/2 times our base, 88.8 times our height, 37 inches, and the solution would be 1,642.8 inches squared. Again, we see that we have that inches squared because anytime we're multiplying, we are going to double the units. So instead of just having inches, we're going to have inches squared. Now let's look at perimeter. Perimeter is just like how we did the other one. So let me erase this so we can see it a little bit better. So perimeter, again, is still just the sum of all sides. So it's a little easier to just do and look and see. So we're going to add 88.8 plus 37 plus 96.2 inches, and that'll give us 222 inches. Again, I'm going to point out that that's not inches squared because it's not multiplication. It's just simply addition. All right, and I think this is our last one, and this one is also a little tricky. So let's point out and see, we still see we have our 90-degree angle right here, known as our right angle. And we see this one's a little different because last time, all of our shape consisted of the right angle being inside the triangle and our full measurements being inside and outside the triangle. So let's look at this. So same formula, 1/2 times base times height is for area. So our base is still the same down here, 6.2 centimeters. And notice we're doing centimeters this time, not meters as well. And our height is actually, and this is a little deceiving just because you see 3.1 centimeters right here. But it's actually going to be this 2.6 centimeters because that's what's outside the arrow right here, determining and stating that this is how tall this angle is. So we're going to multiply those together and get 8.6 centimeters squared. Again, we're squaring it. Perimeter, simply enough, we're just going to add up all the sides. So when we're doing that, I want to point out, let me erase that. Sorry. So when we're doing that, I want to point out that we are not talking about this right here. That was the height. So you know how in our other triangles, we have had the height in here with the right triangle. So 2.6 would be right there in our previous examples. Well, we have it on the outside this time, and a lot of students would mistake that as being perimeter, but that is still simply just area. That's not perimeter whatsoever, although the looks can be deceiving right there. So I'm going to leave 2.6 marked out right there. So we are going to add up all of our sides, which consist of 8.5 centimeters plus 6.2 centimeters plus 3.1. And I could see why that could be a little bit confusing to some of our students. But just simply an explanation for that is just because we normally have our 2.6 centimeters inside of our shape, considering it's for area only, not perimeter. So adding all those up, we'll end up getting 17.8 centimeters. All right, let's move on to our next question. All right, so now we're going to look for the area of a circle formula. And the formula for that is A equals pi times radius squared. All right, so we're going to look at our example down here, and we see that our bigger circle, our larger square, has a radius equal to a half of the diagonal of the other square. So we have 10 units, and half of 10 units would be the 5 units. So we're going to plug this in and use our formula. So A would equal pi radius squared. We're looking for the smaller circle first, so let's look. So we would have pi times 5 squared, which would give us 25 pi units squared. So that's how we determine that it's 25 units between the circles. Because of that, we're going to use this other formula. We're going to do a squared plus b squared equals r squared. So a squared is the 5 squared plus 5 squared equals radius squared. So 5 squared, 25 plus 25 gives us 50 equals radius squared, where we're gonna take the square. So that's actually what it equals. So 50 pi units squared. So 50 minus 25. So we get 50. Let me do this so it's not so confusing. We get 50 for the 10 units, and we get 25 for the 5 units. And what we're doing here is essentially trying to find the units between the circles. Like, what is the distance between these circles? So 50 minus 25 is still 25. So the units between the circles is still 25 pi units squared. Because if we were to square it, it would be 50 units. But taking half of 50, and as we stated earlier, we could tell that the larger square had double of the larger circle was double than the smaller circle. So 25 plus 25 does in fact equal 20, and half of 50 does equal 25. So that's just a good way to check our work and to make sure that we're doing everything appropriately. All right, see, they are all the same. All right, so looking at our next question, we are going to find the volume of the cone, the area of the circle, and the volume of the silicone. And we have 3 shapes here. 1, 2, and it might be a little hard to see because of this image, but I believe that it was the best visual for you guys to see, where we have the cone, the cylinder, and the sphere. See, the sphere is the circle, the cone is that, and then the cylinder is what's holding it all on the inside. And I'm going to erase that because that was pretty bad. But I am going to leave the 1, 2, 3 because I think you could see it a little better like that. So the volume of the cone, the formula for that would equals 1/3 base times height. The area of the circle is A equals pi radius squared, which we just did that. Volume of the cylinder cone equals B equals 2/3 pi radius cubed. All right, so that's how we would find the volume of the cone, the third image. So we did the third image, so I'm going to mark that out. So the volume of the cylinder, which is number 1, I'm going to write that on here. That way we could see which one I'm talking about when I'm talking about it, so you could actually see that. I'm going to rewrite that 3 for you. We already did the cone. Now talking about the cylinder, that's number 1. So the volume of the cylinder would equal base times height. The area of the circle or cylinder would equal pi radius squared. Volume of the cylinder would equals 2 and it's, it's all kind of the same, but 2 pi radius cubed, it's all kind of have the same, kind of formulas like that, but the numbers are different for each one. So the volume of the sphere would be equal 4/3 pi radius squared. All right, so now we know the formulas, and now we're going to actually do it. So the volume of the cone, as we said previously, and I'm going to mark these again. So let's do the cone first. That's number 1, the cylinder's number 2, and the spear's number 3. Hopefully you can see that, and hopefully that helps a little bit more. So the volume of the cone, as we said before, was V equals volume equals 2/3 pi radius cubed. And then we're going to divide it by 2/3 pi radius cubed equals 1. Volume of the cylinder, volume of the cylinder is 2 pi radius cubed divided by that as well, and that will give us 3. Volume of the sphere is 4/3 pi radius. Divide that by, and I'm pretty sure that's supposed to have. No, that's right. Sorry. Volume would equals 4/3 pi radius. Divide that by 2/3 pi radius cubed, and that will give us 2. I'm pretty sure that's supposed to have a cube there. So let's just say we did that. So the ratio would be, and I just put it in order even though it's not order in here, or up here where you visually see it. It's actually ratio of 1 to 2 to 3. Which I have in the order of 1 to 3 to 2, but you want to put it in sequence like that, 1 to 2 to 3. So now we're going to find the area base, and using our right trapezoidal prism. So, So our formula is 1/2 times A plus B times height. So A equals the top length, B equals the bottom length, and H, of course, always equals height. Oh, sorry. So B would equal 1/2 times 17, which is the top length, plus 26, which is the bottom length, because if we were to set that prism up, 17 centimeters would be the top, and 26 centimeters would be like our base bottom. And then our height, of course, if we were to set it up, would be 12. And some may assume this 15 is our height, and it's not because it's slanted. We want the overall height. So after multiplying after multiplying that, we're going to get our base. So we did 1/2 times 17 plus 26 times 12, and that will give us 258 centimeters squared. Now for perimeter. Again, we are literally just adding up all of our sides. And we're not going to add up this 4 here because that 4, again, is, of course, with not with perimeter. So we see 26 is that side, 12 is that side, 17 is this side, and 15 is that side. So adding those all up, we get 70 centimeters. And again, I want to point out that when we're doing perimeter, we're not going to double the units because we are not multiplying. We're still just simply adding. Not including the floor. Again, I'm going to go ahead and repeat it. We're not including the floor because it measures the height, not the perimeter. So that would go in the inside. Like previously when we said the area, normally we would have that in the inside. But that is just the height for this corner, not for the overall height. Okay, so moving on. Now we are going to find the surface area of our right trapezoidal prism. So surface area formula would be 2b plus p times h. Well, b is of course our base area, p is of course our perimeter, and h is of course always our height of the trapezoidal prism. So B would be 258 centimeters, and let me show you where we got that from. We got that from right here. We've already solved for our base area. So all we're going to do is plug that in for B here. So 258 centimeters, and perimeter was 70 centimeters, which we have just solved out on the previous slide as well. And now it's time for include our 4 centimeters because now we are talking about area. So when we're talking about area, now we're talking about the inside, the height of the corner right there. which is 4 centimeters. So plug and chug that in like usual. So this is how we're going to find surface area. 2 times our base, 258, plus 70, which is our perimeter, plus our times our height, which is 4. So surface area equals 796 centimeters squared, which I could have just put a 2 right there, but it's centimeters squared. Pretty easy. Now let's do another one. This one's image is a little bit different, but it's still the same concept. We're still going to have a base area of 1/2 base times height. We have different numbers, but overall the formulas always remain the same, and that's kind of like the constant with math, is we're always going to have the same formula. It does not change, but our numbers will change. So our answers will always be different. So we're going to kind of do like what we did before. We're going to find the base area first, and then we're going to plug and chug for surface area. So base area is 1/2 times B for base, which is 15. We see that this is our base down here, just 15 times perimeter. And if we were to add all these sides up, we would get, we would add them all up, and then we multiply by our height, which would be the AM. So doing all that together, B would equal 60 meters squared. So perimeter, adding all those up, we would get 8 plus 17 plus 15, and we're not going to include the 7 because that is also for height. Like we said before, we are not including area, we're just talking about perimeter simply here. So now that we found our perimeter and that we found our base area, which is 60 meters squared, and 40 is our perimeter, we are going to plug and chug like we did before. So our surface area is 2B plus pH. So 2 times base, which is 60, plus 40 times 7, which is our perimeter and height. Again, so that's where we're getting 7 from. This is our height. So when we're not talking about perimeter, we're talking about area. So that's how we're finding our surface area here. So plug and chugging that all, our surface area would end up equaling 400 meters square. So this is what we did before. It may seem a little bit different because I did it in a different sequence this time. As in previous before introducing it, I wanted to do the base area first. Well, you would have to do base area first anyways, just to be able to do surface area, but I did it on its own slide. Therefore now I did it all on one side. So hopefully this is making a little sense, and it may seem a little chaotic, but I wanted to be able to introduce that slowly and then introduce this and get a constant speed going on it. So this one might get a little messy. So let me move you over here. So the volume of the sphere would equal, which is our formula, 4 pi radius squared. So we have 2 hemispheres equal 1 sphere, and we have 1 cylinder. So the surface area sphere equals 4 pi r squared. The lateral area is 2 pi r8 times height. Sphere volume is 4/3 pi radius cubed. Cylinder volume is pi radius squared times height. So let's take a look. Sorry. So surface area would equal, which I just put S because it's easier to do that when talking about all of this. S equals 2 pi radius height plus 4 pi r squared equals 2 pi, radius is 4, times our height, which is 21. And how we found radius is because radius is, we see that this is our center, and I talked a lot about this in our Team Teach with my associate, Katie Hardister. When we're talking about radius, that is our center. So we're going to take half of that. So half of 8 is 4, so that's why we got 4 there. Just wanted to point that out, and we got our height right here for 21. So, and then we're going to add 4 pi radius squared, which radius is 4. And that will end up giving us 729 feet squared. And again, when we're multiplying, we are always going to have a square. All right, now when we're looking for volume, volume equals 4/3 4/3 pi radius cubed plus pi radius squared times height. And we're going to use the same numbers and plug and chug as well. So 4/3 times pi, and I'm sorry if this looks a little bit messy, but I feel like it's easier to have it written out beforehand rather than me trying to slop it all down for you guys. So volume equals 4/3 pi times our radius, which is 4 cubed, plus pi radius, which is 4 squared, times our height, which is 21. So volume would equal being 1,324 feet cubed. And we did cube because that's what our measurements here are. When we're talking about volume, we are talking about cube, our 3D dimensional object. All right, so I'm going to move you back over here. Sorry. So we're going to talk about the surface area of 3 different things. Here, we're going to talk about a circle, a cone, and a cylinder. So looking at this, our surface area of a circle is pi radius squared. Our surface area of a cone is pi radius times the slant height, and I'll talk about the slant height in just a minute. And then our surface area of a cylinder is just 2 pi radius times height. So, and I'll talk about slant height in just a second. So surface area would be, for a circle, we're doing first, which is pi times our radius, which is 2, squared, plus, and we're adding we did our circle first, so that goes to our circle, plus our cone, and then plus our cylinder. So let me explain that a little bit. So we did circle, so now let's find for our cone. So we know, So we know cone is pi times the radius, which is 2, times the slant height. So I'm going to show you what the slant height is because I don't think it's ever been just thrown out there because we know how to find height. So our height here would be 10 meters, but our slant height, we want to look at the slant of our object or shape. So our slant height would be this 6 meters right here. And I never really, I guess I just guessed that was it, but I never really distinguished the difference between height and slant height. So it's a good thing to point out. So our slant height is 6 meters, plus our cylinder surface area would be 2 pi times the radius, which is 2, times the height, like I said again, which is 10 meters. And so our surface area would end up equal 176 meters squared. So the volume of the cylinder is pi radius squared times height. The cone is 1/3 base times height squared, times 2, sorry. So volume equals radius times 2 squared times 10 plus 1/3 times radius times 2 squared. And then we are going to use the Pythagorean theorem to find our question mark. And I'm sorry, this is also a little bit sloppy as well, but just bear with me, and it will all make sense at the end. So if our H2 up here with our cylinder, our cone, equals 6 squared minus 2 squared equals 5.66. So volume equals pi radius squared, which is 2, times 10, plus 1/3 pi times 2 squared times 5.66, because we solved for a question mark there. That's what I meant by it'll get a little bit more understanding after we solve for certain materials first, and then we just plug and chug from there. So we got our 5.66, and that will end up giving us 149 meters cubed. All right, well, I think that's all I have. Thank you.